Okay, hello all you crazy people out there, my name is Michael, and welcome back to another video on 3D collisions in GameMaker Studio 2. So, this is another video going to be pertaining to the Bullet Collision DLL. Once again, if you want a solution that works in native GML to be a little bit more cross-platform, I'm going to get to those later. Raycasting. Raycasting is where the fun begins, at least so I think. If you think it sounds familiar to the ray tracing phenomenon that's taken computer graphics by a storm in the last couple of years, you would be sort of correct. They both have to do with tracing lines through a 3D world and then doing things when the lines make contact with something. But I am talking about collision systems now and not 3D graphics. So, if you have ever wanted to project a one-dimensional line into 3D space and see if it hits something, perhaps you have a bullet flying from the tip of a gun, or as I accidentally did there when I clicked the mouse, a ball that can be approximated by a single point in space flying through the air, or perhaps you want to allow the user to click on the screen and select whatever they click on in 3D space. That is something that you would use raycasting for.
Hey.
Again, raycasting is just projecting a one-dimensional line into space instead of a three-dimensional object. So again, I think that's pretty exciting. I am going to get out of that little demo program. This is the state of the program I have now. This is the state of the program after the initial 3D collision video. It's pretty much the same as the little preview that I just had up, except for the part where you click and throw balls off into space. So I'm going to do a little bit of setup. Firstly, the ball in question is a 3D model. If this was old GameMaker, I would probably just say D3D draw sphere, but since this is not old GameMaker, and everything must be a vertex buffer, even though D3D draw sphere was just a vertex buffer under the hood and you just never saw it, I am going to drag that file. Did that actually go in there? That did not go in there. Ball.d3d into included files to add it to the project. After that, I'm going to create an object to represent the ball. Let's just call that ball. And it is going to have a model, which is the ball. Every instance of ball is going to load its own model. Yes, I know that's inefficient. No, I don't care right now. It is going to have... I finally caved and decided to just kind of hijack depth to serve as a z coordinate. For no other reason other than that you can pass it to the instance create depth constructor, and you can essentially create it at a 3D point in space. I'm going to give it x speed. I'm also going to give it y and z speed. I'll worry about gravity later. And alarm 0 can equal 1,000. And I'm just going to, in alarm 0, instance destroy myself. Just so that the game won't slow down gradually if you click over and over and over, because the balls pile up without ever getting cleared.
Hey.
Next thing I'm going to do, I'm going to uncheck the visible check mark. In the object properties, I'm going to add a draw event, and that sounds counterintuitive, but I'm going to store this code in the draw event, but I'm going to be drawing it from somewhere else. I just copied and pasted this in from my demo project. I hope I don't have to explain how vertex submit and matrix set, matrix build work anymore, since I've already covered those fairly extensively. Let's go into the camera draw event. This is where we will be drawing the actually drawing the ball, because draw order is important. And in the end of the camera's draw event, after everything else has been drawn, then we'll draw the ball. You could make this work with depth, and you could make the ball visible on its own. I do not like dealing with depth. In any case, the ball's depth is set to 0, because once again, I'm hijacking that to work with to serve as the z coordinate. Okay, nothing should have changed. None of those balls are actually being instantiated. The only thing that really would be different is if there was a compile error and the game wouldn't run for some reason, but there is not. Okay, let me go back to my notes. Everything else looks good. So again, in the name of setup, let me go into not the player's create event, but the player's draw event. I am going to once again copy and paste code in from the demo project. This is just GML. You should be able to at this point know what this does by looking at it. When you click the left mouse button, you're just going to create a ball and have it be thrown in the direction that's in front of you. It's not going to collide with anything or anything. It's not going to collide with the ground. Nothing is happening. I have a feeling that's because the ball is invisible or something. Oh, okay, it's being created at the world origin. Or at the player's feet, rather, I should say, not the world origin. And that is because, haha, I've written code before, I swear. Let's go to the step event. Let me copy and paste in some more code. We are just going to update the ball's actual speed. So now I throw the ball, it flies off infinitely and off the screen. I can't see it anymore because I don't have super good look over making the player look up. Okay. Have I looked at gravity? What would be a good gravity value? Let's super hard code this in 0.1. No, wait, help. Alright, now it will at least fall back to Earth. Was there a reason that I decided not to add that part when I set up the ball? There probably was, and it was probably stupid because it's easier to see that way. Alright, the ball doesn't actually curve, but when I move the camera when it's flying, it looks like it's curving. It's curving downwards, obviously, but not side to side. So let's make this collide. Let's raycast this. How long am I into this recording? I am 10 minutes into this recording. I took 10 minutes to set this up. I mean, that's going to get cut down a lot, but boy, do I like to take my time. So raycasts, as it turns out, can be pretty simple. In Bullet, it's just one function call. So you can say if c raycast world, and this will perform a raycast against the collision world. You can say x from is going to be the ball's current x, y is the current y, z is the current z, x2 is going to be x plus x speed, y is going to be y plus y speed, z is going to be z plus z speed, and just like with regular collisions, or at least with the collision objects, this takes a mask, which once again, if you don't know what that is, just make it 1 for now. I will explain those in a future video. Masking is a lot of fun, and I want to talk about it one of these days. I set up a demo for it, finally. I don't know if I'll record that today, though. Anyway, if this returns true, if the raycast detects something, the annoying, like, high school teenager in me wants to point out that this isn't actually a ray. This is a line segment. A ray would be something that extends out to infinity, but since we are specifying a starting point and an ending point for this raycast, it is not an actual array, it is a line segment. Just want to get that out of the way. In any case, if we find something, how you handle the fact that you are about to collide with something is up to you. In my case, since I just want to demonstrate what's going on here, I'm just going to set all the values to 0. It would be equally valid to have some sort of response from the object that you hit, or have something else happen. In my case, you can see the ball is just flying off, and now it's getting stuck to the things that it's landing on. And I was hoping I would be able to hit the purple thing. There we go. My aim is good. I like throwing stuff. It's not colliding with the floor because the floor doesn't have actual collision information right now. If you were to put a plane under the player's feet to serve as the floor, then the ball would get stuck to it when it hits something. Otherwise, if I back far enough away, you saw briefly, it sank below the floor and off into the abyss. And in about 16 seconds, it's going to get deleted because that's when the timer will expire. Okay, so there's a little bit of information that you can get out of collision, checking. You have a few functions that say C hit X, C hit Y, and C hit Z. These are the exact points where the collision happens. I believe these only work for raycasts and not collision overlap checks. They might work for overlap checks. In any case, as I said, these return the exact position where things hit. If I were to run the game again and look really closely at where a ball sticks to one of these blocks, let's see, is that going to hit? That flew over your head. My aim is, I didn't say my aim was that good, except I did. All right, so if I were to put the camera really close to this, which I can't really do because I didn't give myself super fun control over the camera, you would see that the ball is not actually stuck to the block. It is actually stuck to the previous position before it were to hit the block. That's an age-old collision problem in GameMaker, moving objects that are about to collide up to the point of collision and exactly ends no more or less. If you wanted to do that with the ball, you could simply say x equals c hit x, y equals c hit y, z equals c hit z, and that would position them perfectly. Let's see if I can actually hit the block on my first try. Cool. And now you can see the origin of the ball is the center, and the center of the ball is exactly on the side of the cube. It looks like it's sank halfway through. If you want to actually give the ball volume using collision checks, you would either use a sweep, which you can think of as a raycast, but with a 3D object with volume, or you would have to do all sorts of black magic sorcery with the radius of the ball and stuff. Yeah, sweeps are essentially raycasts, but with 3D shapes. They're one of the things that Bullet does that P3DC just doesn't do at all, and they have their uses. And to be honest, I kind of feel like I should be using them in a lot of situations where I generally don't use them, and I feel like that would make my life easier. Anyway, there is also, if you want to make things bounce, and I feel like I'm not qualified to talk about this because this gets into using dot products, and when I see dot products, I run away screaming. But there's also, you can also get the normal of the surface that you hit. And for those of you who remember high school physics, who probably also want to run away screaming right now, that's, the normal is the perpendicular vector out of the face, out of the triangle. If you want to make something bounce, whether that's a ball or a bullet, I don't know how often you're going to be making bullets bounce unless you're doing some sort of really weird, like, pandemonium weapon or something like that. Or if you wanted to do lighting and you wanted to reflect light off of something, you would reflect it over the normal vector of the surface, and that's where the dot product would come in. This is going to be, what, the third, fourth, whatever future video topic that I invoke in this video. I want to keep this reasonably simple. If you look in the collision example project that I included with the GameMaker asset package in the last video, that has balls bouncing off of surfaces using the normals and dot products. If you want to poke around with that, and if you want to make stuff bounce, that should be enough to that should be enough to get you started. If you're the sort of person who prefers to hear things talked through instead of using text or just poking through code, let me know, and I may just dedicate a video later on to making stuff bounce, because making stuff bounce is fun. Let's be honest. One of the many games that I want to make before I die is some sort of sports game, which probably means baseball because I don't really pay attention to any other sports, and making balls bounce off stuff is at least like 10% of the reason I want to do that. That's neither here nor there. Also, before I accidentally don't mention this, because this is also important, C hit object. This is something I will definitely be talking about in the future, because this is how you identify the objects that you're colliding with, or the objects that you're raycasting into, whether they're the floor or an enemy or an NPC or lava or something like that. And C hit fraction. This can be used for getting the distance to the object that you're hitting. I believe this returns a number between 1 and 0. Yeah, between 0 and 1, with 0 being no distance, so it would be right in front of you, 1 being the entire distance, and 0.5 being the halfway point. It's worth noting, I don't believe C Raycast World actually returns true. I believe this returns the distance to the object. Nope, it's just a true or false. It does not return the distance to the object. Okay, so if you want to get the absolute distance and not the fraction to the object that you hit, you would want to say something like point distance x, y, z, c hit x, c hit. And maybe let's not do that after x, y, and z have the values reassigned. And this would, this needs to be point distance 3D. Fun fact, the 3D distance formula is exactly the same as the 2D distance formula, it's just done twice. Here's a diagram of how that works. I probably found it on Wikipedia. If you've never thought about that before, you're welcome. Your mind has just been blown. Anyway, this is how you would get the absolute distance to your target. If I were to just show debug message this, I could probably say something like that. Print out the distance to the collision, and we are good to go. All right, let us try and actually hit my thing that I'm throwing at. That was too far. That stuck to it. Okay, you can see the distance to the collision on the according to the thing in the console is 3.8. That's interesting. That could be useful in certain situations. Maybe you're making a first-person shooter game and you want harder shots that are harder to pull off to be worth more. So if you snipe someone from all the way across the map, it does extra damage or something like that. There are uses for that. Anyway, I believe that's all I wanted to talk about today. I also believe that's the second time I've said that in this video, which tells you something about how prepared I am right now. As always, if you want the code for this, link in the video description. GitHub, all the usual stuff. If you did not see the introduction to Bullet Collision DLL video that I made, one, you should probably go watch that because that does a lot of the setup for this video, and two, if you're looking for the actual DLL and files that go with it, that go with this, those are probably also in the video description if I remember, which I hopefully will remember. What other housekeeping things? I've started a Patreon for these videos. If you want to chip in and join the fun, links in all the usual places. Otherwise, my name is Michael. I like wizards. I like dragons. I like making games. I try to post 1 or 2 of these a week. I hope you all enjoyed that, and I will see you all later. Special thanks to Indie Punch and Zenith for supporting these videos. If you want your name in the credits and to force me to try and pronounce them out loud, head over to the Patreon page in the video description and join the fun. I am the all-time worst salesman ever.